morning. My name is Matthew Lee, and for the past week, I have been doing a project of measuring hair with lasers. I know it's weird, but materials and information. Each for the materials are basically simple. All you have to do is just cut out a cardboard 15 by 15 piece, and then cut a 10 by 10 square inside of it. And then you just grab any hair that's at least 15 centimeters long, so that way it's able to reach from top to bottom. And then all you have to do is just put a laser right behind it and shine. Depending on what kind of laser it is, like a red laser is typically can be around like 650 nanometers, and a green laser can be around 520 nanometers, depending on how intense or how big your laser is. For the project that I did, I used a 632.8 nanometer laser, which is the laser that I just set up for you guys right there. And as you can see, for my objective was to measure the width of the hair using only a laser. And if you guys look closely, you see this little red dot, and that's the laser that's hitting the hair, and it's causing this image to show. Does anybody want to take a guess as to why you see like these little diffracted, blocks, these black little lines right there, kind of separating hyphens? Sorry? Yes, he is right. that is the interference, because once the laser hits the piece of hair, it causes a constructive and destructive interference. This is kind of like a little drawing I showed that proves that this is a constructive and destructive interference. As whenever these two waves they hit or they intersect each other, that causes a light part to show. That's why you see this dot right here. Say this middle piece is the hair, and then the light shines right here. That's why all this intersection causes the light to show, and wherever it doesn't intersect, it causes these black spots to show. So what is constructive interference and destructive interference? Constructive interference is caused whenever light waves are able to pass through or travel to a place without any interference. Typically, constructive interference have matching light waves, just like it shows right here, because whenever they have matching light waves, and the light waves usually have to be like whole numbers, they can add up, and that's why it equals to here or equals to that. That's why the light waves are showing. But destructive interference is caused whenever there is an interference when the light waves are broken up or switched or some kind of misplacement. As you can see, this light wave is not the same as this light wave, because this causes the interference to flatline, which causes the black spot or the black stuff, kind of like the breakups in between. So throughout this week, I've been recording my data, and I've ranged for my second experimentation. I ranged around 60.1 for the measurements, and that's really good. I mean, no hair is the same. Like everybody has different types of hair, like thick, thin, smooth, rough. So the range from a piece of hair, a good decent result would be like 50 to 100 micrometers, which is pretty good. So, but my first experiment, I landed around 73.1, and so that's also a really good one. Here is another example of destructive interference. Whenever the light waves are not equal and they kind of reflect, or they kind of break off. And that's basically my presentation. Does anybody have any questions?